All right, we will finish up this week talking about Le Chatelier's principle. And what Le Chatelier's principle says is that when a reversible process, meaning one of these irreversible reactions that's could reach equilibrium, when that's disturbed, it will proceed in the direction either forward or reverse in such a way that the stress on the system is relieved. There are four things that could possibly affect the equilibrium, and then we'll look at the ways that a system would react if it's affected that way. So there could be a change in the concentration of some of your substances, either on the product side or the reactant side. There could be an increase or a decrease in pressure. There could be an increase in a decrease in pressure, or temperature rather, or you could deal with a catalyst, and we'll talk about that. So let's start with concentration. So the reaction is going to shift away from the side to which a substance is added, which would bring your system back to equilibrium. So there will be an effect on the system, but the equilibrium constant is not going to change. So let's look at this reaction here. In this reaction, where you have sulfur dioxide and oxygen reacting together to form sulfur trioxide, if you added more sulfur dioxide, the reaction would, which way do you think it would shift? If you added more reactant, this equilibrium is going to shift in a direction so that you can make more product to get rid of that extra reactant that's there. Okay. Likewise, if you were to have this system in equilibrium and you just decided to throw in some sulfur trioxide, then the equilibrium would shift back to the left temporarily until you used up that extra sulfur trioxide. But then equilibrium would be reestablished and the concentrations would go back to the same ratio. So you would not have a change in KEQ because eventually it would all get back to the same, because remember, this is just a ratio because you're taking concentrations and dividing them. So you're going to get the same ratio in the end. It's just going to, if you add more reactant, you're going to make more product. So the ratio is going to balance itself out. If you throw in more product, it's going to shift back the other way to make more reactant. So again, your ratio between your products and reactants is going to stay the same. Assuming nothing else changes. You're not affecting temperature, not affecting pressure, you're just changing the concentration. So it'll take a little while, but once the equilibrium is reestablished, the KEQ is unchanged. And what happens if you change the pressure of the situation? Well, if the pressure increases, you're going to see a shift. So if you increase the pressure on your system, press down on it, the reaction is going to shift to the side with fewer gas molecules because there's more room over there. If you let up on the pressure and you give the system, in a sense, more room to move around, the reaction is going to shift to the side with more gas molecules. Now, if you have a system where the numbers of moles of gas in the product is the same as the number of the moles of gas in the reactant, they're not going to have a change in KEQ. But let's see what happens otherwise. So in this reaction, same one we had before, sulfur dioxide reacting with oxygen, you have 3 moles of gas on the reactant side, 2 moles of gas on the product side. If we increase the pressure on this system, that's going to affect more the more crowded side. It's going to affect the more crowded side more, so it's going to shift toward the right to decrease the stress of that. You'd make more product. Then the KEQ actually would change. But if you decrease the pressure, it would go back because there's more room to move around, so you can make more reactant because there's more moles on that side, more moles of gas. But let's look at this situation. Here we have equal moles. 1 plus 1 is 2, and then 2. So changing the pressure does not affect the equilibrium constant at all, okay? Because the moles of gas are the same on the product and the reactant side. Now what about temperature? All right, this will affect your, you'll have to look at whether their systems are exothermic or endothermic. So if a reaction is exothermic, meaning it's producing heat, then increasing the temperature is going to increase the product. So the equilibrium is going to shift to the left. Okay? Now, I also want to point out while I'm talking is that on page 391, there's a table that breaks this down by all of the, it's an action here, I'll show you. Okay, whoop, let me get it the right way. There, this table, it's titled Table 15-2, the effects of stress on equilibrium concentrations in KEQ. I would recommend looking at that as you go over the homework questions. That's actually a very succinct way of showing these shifts and how Le Chatelier's principle actually works. Okay. So if you have an exothermic, going back to this, you're going to want, so if you have an exothermic reaction and you add heat to it, that would increase the amount of product, but you don't want that. So in order for equilibrium to be established, it's going to have to shift back to the left. All right, in an endothermic reaction, when you have to have heat, increasing the temperature is going to would naturally increase the reactant. And so we don't want that to happen because we want to maintain equilibrium. So you're going to shift to the right so that you counteract that by making more product. The KEQ at different temperatures will change. It just will. So because everything is either endothermic or exothermic. So changing the temperature will affect the KEQ regardless of whether you increase and it's exothermic, whether you increase and it's endothermic, whether you decrease the temperature and it's exothermic or decrease the temperature and it's endothermic. It's going to have an effect on the KEQ. So here we go. Same reaction, but now I'm telling you it's exothermic. All right. So if you add heat, then reaction would naturally shift to the right. Excuse me, adding heat would be like adding a product. So if you want to maintain equilibrium, you're going to have to go to the left. If you take out heat, it's going to make the reaction go to the right because you want to add more, increase more heat. So if you increase the heat on an exothermic reaction, you're adding more product. So you're going to want to shift it back to the left to maintain equilibrium. Likewise, if you take out heat, you've got to maintain that equilibrium and you're going to shift it back to the right. Here's an endothermic reaction with the opposite. If you add heat, you're adding more reactant, or yes, excuse me, you're adding more reactant and you're going to shift it to the right to maintain equilibrium. Okay, so whatever you add, you're going to ultimately have to remove. So you have to, your reaction is going to be altered one way or the other, depending on whether you need more heat to maintain equilibrium or you need less heat to maintain equilibrium. Now, a catalyst is something that speeds a chemical reaction along. Now, it does not affect the equilibrium constant. But what happens, a catalyst does affect chemical reactions. It lowers the activation energy so that the reaction can move faster. So what will happen is if you add a catalyst, it does not affect how much product or reactant is made and the ratio in between, but it can allow you to acquire equilibrium faster. All right, I'm going to stop there and just look for more problems posted with this video, and that's what you'll need to do. I hope you guys have a great weekend, and I hope to hopefully I'll see you in office hours, and I will talk to you soon.